Hello everyone, I am Kush. In this video, we will solve one problem about electric charge. You have three identical spherical metals. Sphere 1 has a charge of negative 8e. Sphere 2 is uncharged. And sphere 3 has a charge of 12e. Sphere 3 is first touched sphere 2, then it is touched sphere 1. Then they are arranged as in the figure. Calculate the magnitude and direction of the net Coulomb force on sphere 2 due to the other two spheres. Coulomb constant is K equal to 8.99 times 10 to 9 Newton meters squared over Coulomb squared, and elementary charge is E 1.6 times 10 to negative 19 coulombs. After the first touch, the total charge of spheres 2 and 3 is shared equally between each sphere. Namely, they would be equal to Q2 plus Q3 over 2. Q2 is 0, Q3 is 12e, then the result is 6e. Therefore, we can write 6e for sphere 2 and sphere 3, but the charge of sphere 1 does not change. After the second touch, the total charge of spheres 1 and 3 is shared equally between each sphere. Namely, they would be equal to Q1 plus Q3 over 2. Q1 is negative 8e and Q3 is 6e. Therefore, we write negative e for spheres 1 and 3, and sphere 2 remains constant. Anyway, now let us solve the problem. The Coulomb force on sphere 2 due to sphere 1 is an attractive force. By the same way, the Coulomb force on sphere 2 due to sphere 3 is an attractive force. According to the numerical values and the figure, the magnitudes of these forces are equal. Namely, F1 equals F3, and they are calculated to be K times the absolute value of 6e times the absolute value of negative e over r squared, where r is the distance between 6e and each negative e. So we write 6ke squared over r squared. According to the figure, it is easily seen that the y component of F1 and F3 are equal. So they are gone. We are left with the x components of F1 and F3, which are F1 times cosine theta and F3 times cosine theta. So the net force on sphere 2, which is F1 plus F3, is calculated as 2 times F1 times cosine theta I hat, because the net force is in the positive x direction. If we put the expression for F1 into this equation, we obtain 12ke squared cosine theta over r squared I hat. From the right triangle in the figure, r can be found by the Pythagorean theorem as square root of 20 centimeters. And again, from this figure, cosine theta is found to be 2 over square root of 20. Now we can put the numerical values into this equation. The value of k, the value of e, the value of cosine theta, and the value of r. Here, since centimeters is not an SI unit, we convert it into meters. So we obtain square root of 20 times 10 to negative 2 meters. Finally, we add the direction of the F-net as I-hat. As a result, the calculation gives 6.18 times 10 to the negative 24 newtons in the positive x direction. Okay, this result brings us to the end of the discussion of this problem. Thank you for your attention. See you in the next video.